Graphical user interfaces can be a little tricky, mainly because of the multi-threaded nature of them and the notion of events. With Java Swing, all user interface events are handled on a separate thread known as the event dispatch thread. The event dispatch thread is pretty much the hidden glue that makes action listeners actually work when you hook them up to buttons and other user interface components. So user interface events can be tricky because once we wire them up to a listener, from that point forward the method event can be called pretty much at any given time, and we don't really know when it's going to happen, and we don't have a lot of control. So the program I have here is a demonstration of one thing that can go wrong, and then later we'll see how we can use multi-threading to solve the problem. So a quick walkthrough of the code. Here's our entry point. I have two print statements from main just to demonstrate that the main thread continues after setting up our JFrame with the action listener. And that just shows you that the main thread is not what's handling the JFrame with the action events after it's set up. So we just make a new instance of this class called freezing UI, and in the constructor we just basically set up the JFrame and add a simple button. And if you notice, our class implements action listener, so we need to override this action performed method, and by doing that, when we create our button we can add a click event, and we can pass it this, which is saying the click event for this button is handled by this class. And we're able to do that because this class is an action listener. So all the button does is increment the counter, set the title of the frame, print to the console, and then call this download method. And similarly, the download method just prints a couple things, and we use a thread.sleep. And what we're doing with the download method is just pretending like we're performing some action that can take a really long time that we don't have control over. So downloading something from the internet is a good example of something that can take quite some time and we don't have control over, and we can't really predict too well because it all depends on how big of file you're downloading, your internet speed, the rate at which their server can spit out the file to you, and a whole bunch of things. For example, in the middle of your download, a tree could fall over and snap the cable that was handling your internet connection. So all in all, the download method just represents something that can take quite some time. So when we run this, you'll see we got our main thread prints, but our application is still open and the click events are still being handled because those are on other threads. And it's simple, we just click the button, it prints some things out to the console and updates the click count. So the problem arises when we perform some action that takes a noticeable amount of time directly on the event dispatch user interface thread. So right now the thread.sleep doesn't sleep at all. So let's change that to 3 seconds, for example, and let's take a look at what happens to our user interface. So I can click it. Oh, that's weird, the button kind of froze in the click position. Usually that's supposed to snap right back out of it. So let's start clicking it faster. So nothing's happening when I keep clicking it, and these requests are building up. The UI is not really updating as responsive as it should be. And if I click a bunch of times, I can't even close it. So it doesn't work. It just breaks the user interface. So if we had other user interface components, it could cause issues with those too because it's working on the same thread. So the moral of this is, if you need to do something that can take a noticeable amount of time on the user interface thread, it's probably a good idea to spin that task off on a thread of its own so that your user interface thread can continue and your user interface will remain responsive and act appropriately. So let me try to figure this out quick. So the idea is we want to call download on a thread of its own. So let's make a new thread. I'm going to do this in what's called an anonymous way. So the normal way would be thread equals new thread. And we're creating this variable that refers to the thread we're creating. So what an anonymous creation would look like is we don't actually create this variable handle to the thread. We just say new thread, and if you remember from the last video, it takes a runnable. So let's make an anonymous runnable to give to our anonymous thread. So I'll say new runnable, and that should give us an issue because we need to override the action perform, or excuse me, run method, I believe. Okay. So I know this looks a little weird, but we're just creating a new thread with no variable to refer to it, and we're passing it an anonymous runnable, again with no variable to refer to it. And when we make a new runnable, we need to override the run method. So that's why we have this here. So we want to move download into our runnable. And then don't forget, we need to start the thread. We can't just make one. So since it's anonymous, we have to do that on the same line. So after creating the thread, creating the runnable, overriding run, we can add the dot start here. And yeah, so the syntax is a little goofy, but usually you'll see this in situations where you know you just need to make a thread and run it, and then once it's done, you don't care about it after that. So it saves a little bit of code by not having to actually make new instance variables that point to each of these things. So hopefully now, even if I were to change this from 3 seconds to 10 seconds, after I click the button, our user interface should at least remain responsive still. So yeah, and that's the case. And since each download is being spawned on a new thread, you can see we've started 4 downloads, and they all finish. And that's a little weird that it's using. Oh, so yeah, when it finishes, it just refers to this single click count variable, which is incorrect for this method. But you can see we can start parallel downloads and download multiple things at once. So that's one way multi-threading can help us keep a responsive user interface. But this introduces the question of, what if we need to return a value from download? So what if we said this was a Boolean, and if the download is successful, we return true, and if not, or I'll move that here. And if there's an exception, we just return false. I'll demonstrate the solution to this in the next video, but to demonstrate the problem. So our code is running and it goes down line by line, and we make a new thread and spin it off to download something. Well, our click action performed is finished, but what if we need the return value from download later? How do we get that?